Hey, everybody. I am C83. Our last two issues, we talked about what 99% of designers don't know. Color design also requires the top and middle parts of the color language. And let's talk about the next part of this issue. We talked about the 1 to 8 regularities earlier. Its color is the main element of language composition. We now come to part 9. Language combination law attribute. You all know that the components of all color languages needs his own laws. If your color language is irregular or belong to no boundaries, then color design is basically impossible to achieve. That's why we have boundaries, why we have rules. Only with regularity can we have self-consistent logic, so we can quantify the color. Only energetic colors can be designed. Colors that cannot be quantified cannot be designed. Let's take a look at its hue law and color position law section. We can clearly see the regularity in the CDS color system. That is, it has 8 shades, and the first half of the color is equivalent. For example, T100 or B100 or G100. Another of its regularities is also expressed in chromatic equivalence. The second thing we'll talk about next is that it's the same in color positions. It has 3 elements: blackness, whiteness, chroma, which add up to 100. If in the hue circle, it's a single hue position. It's an independent color. For example, T100 and B100. Then the color coding system behind them. It just shows how light or dark the color is in front of them. This is its color regularity. When we have this regularity of color, in fact, the color system of colors exists for us. For designers, it becomes an auxiliary function. So we have the code for this color. We know for sure what color is the designer describing. For example, I gave you a color of R100. You know it's pure red. And there is a B01, W01 behind the R100. Then you know it's a very vivid red, because our red C is 98. 3 of them add up to 100. This is its inner logic and its regularity. You have this logical regularity. You have the ability to code for over 400,000 colors in your head. Because we are here, there's been a lot of visual psychology experimentation and training. Master the design and learning of a set of color coding systems. It will produce an infinite number of equally quantified colors. Okay, let's move on to part 10. Language self-consistent combinatorial logic. Combinations must be logical in order for the language to be self-consistent. If your color language, or the language of any country, he cannot be logically consistent, they will have contradictions and confrontations with each other. Then the language couldn't exist. Either it failed or there is a problem that needs to be fixed. So we're looking at a combination of CDS color languages here. This is its description of the part where we talk about its hue. We know exactly where we can find T21BS79. Let's see, this is T. So what is its color pattern? Let's take a look. If it is T20, B80, you see it's right between this color and this color. It's subtle. You can find a color between 800 colors. So here we have 80, which is actually 800 color codes. The system is inside and we found a color location. This is its logic. And find the code for this color. And you find the signature of this color. this hue signature comes out. Is it made of blue or blue? We see this is blue and this is cyan. Combination color between blue and cyan. This is its logical feature. It's not blue and purple, blue and green. It is blue and cyan. Okay, let's see how to interpret and deal with the next color-bit relationship. The triangle in CDS hue system. It has its own logic. Its combination will find that the combination of B20, W40, C40 is 100. If this point is less than 100 or greater than 100, it's not an exact linguistic representation of color. It's a wrong color representation. Okay, let's take a look at B. We mainly use this color, with this blue color as the core. It's the amount of black. This line extends 20 positions. Let's find a line this is black 20. Then the second one belongs to W. Is this value W this value? They are arranged in the white direction. This line is called white. The white line is. The middle piece he pointed to this point is 40. This is 40. We first have black 20, white 40. And it goes up and down these two intersecting lines. So what we get is a 40 color scale. Then we find that B20, W40, C40, they add up to exactly 100. As I said earlier, if the sum of these three values is less than or greater than 100, it is not the table number of this exact color value. Then this point where the three lines intersect, the combination of their three colors is 100. This is its logical relationship. If it is not, then it is not a representation of the CDS color system. Okay, let's take a look at part 11. Language iteration and quantitative expansion. And I'm going to tell you about that. All color design systems and color languages. There is a total. Because it's not much, may be slowly developing. In certain technological and intellectual and physical experiments and materials, after being developed and improved, its number will increase. But its cost will also increase greatly. So here we are in the CDS color language. We're talking about language iteration and quantitative scaling. It's about its logic, its theoretical relationships and theoretical values, rather than the actual value. The chromatography of the CDS color system. We call it the color Bible. It has only 2,740 colors in it. Enough for designers to design in color. Okay, let's talk about what iterative logic is. This is the standard encoding value of CDS. P100 is the purple, P100. Then B01, W01 looks purple at first glance. It's just that, B01, W is also 01. Color is 98. This is a very pure purple. What's the logic of the encoding? Let's take a look at his blackness, which is 2 digits. His whiteness is also 2. And its hue should also be 2. Our fullness value in the color equivalence is also 00. Color bits are also 2 bits. It is the combination of 2 bits to complete the color system. The color combination of this 2-digit position. We've done a combination of 430,000 colors. And in actual chromatographic design systems, we only finished with 2,740 colors. Let's see how it iterates and expands. This is AP100, we add 2 zeros after it. And B01 we add 2 zeros in front of it. W01 let's add 2 zeros first. Then C98, we add 2 99s in front of it. You will find us all at once. How many more have we added to our data? Added tens of millions of colors. This is his infinite expansion. Because there are more than 2 colors. When it comes to the third color combination, the visual color difference between its two colors is difficult to judge. This is a fundamental feature of the language of color. Therefore, we have adopted a design that is more suitable for modern society and designers. The expression of the colors used. Okay, that's what I'm talking about for you. Color language iteration and development properties. The 11th color of the language law. We surveyed the world's existing color languages. Are not perfect. And in line with this color system. Only color design systems. CDS Carladizer Sister Color Design System. This is no ordinary. The color system we refer to in general. It is a company that owns personal intellectual property rights. Independent color design system and coding. So this is the 10-color coding system. Its typical color language. This is how its hue and hue are expressed. We talked about that earlier. I won't tell you too much here. This is its hue ring. Each of its hue angles in the hue ring. Let me tell you about it. It's color-coded clockwise, not counterclockwise. So orange is associated with yellow. Orange is either related to red. It cannot be staggered by one color to combine. So the colors circle. Hue ring clockwise. This is its color language characteristic. And every color, cultural representations of its range of colors. It's only in the 45-degree range. And there are different levels in 45 degrees. There are 4 different areas of stimulation. And we call this low stimulus, low-medium stimulus, low-intensity and low-intensity stimuli. It's called a 45-degree stimulus. And so on. We have 8 of these hue psychoanalyses. Chromatic triangle. It has 3 sides. One is the blackness side 0 to 100. Whiteness edge 0 to 100. Color edge 0 to 100. Then among their 3 sides, a total of 16 small areas have been divided. Every region. Both represent the degree of strength and cultural characteristics of a color. We have 16 keywords. Its linguistic features in our CDS. The most important of these is, color design must have a color area. So the color area is very heavy. A desired element. We borrow the golden ratio from vision. Divide it into 3 parts. Part of it is the main color. Part of it is embellishment. Some are complementary colors. Complementary colors can be many. Generally, there is only one main color. There can be 1 to 2 embellishment colors. Then the embellishment color must be related to the main color. And complementary colors. They are all characteristics of the use of auxiliary main colors and culture. Okay, so that's what we were talking about. The color language of color design. The 11 most important of these are its causes and characteristics. And then there's the color design system. The 3 main languages in the CDS system. Hue language, chromatic bit language and primary and secondary point language. This is the color design system. A summary of the complete colors of CDS. If the designers are interested, you can copy it as a basic guide for your design. Okay, thank you very much. I share with you. 99% of designers don't know the components of the 11 color design languages. That's it. If you are interested in the color course I am talking about, if you are interested, you can subscribe, like and share. See you next time.